Okay, so this example problem, we're going to use mesh analysis again. I mean, we could use nodal analysis to solve this problem as well. Actually, if you use nodal analysis to solve this problem, it's a little bit easier. You only have two equations and two unknowns. But these videos here, we're talking about mesh analysis, so we want to make sure we do some examples using mesh analysis. Now, the reason I point out nodal or mesh is that on the quizzes, it's not going to specify necessarily to use nodal or mesh. If it does specify using nodal or using mesh, obviously you make sure to use the correct technique to solve the problem. Now, since we're doing mesh analysis, I'm going to draw some loops here. And again, you can draw any loops you want, but typically I draw what are the obvious loops in the circuit. So for instance, there could be a loop like this, and I'll label that. Remember, these loops are currents. These are loop currents. And that's I1. Now, I'll purposely draw I2 in the counterclockwise direction, just so we have something that's slightly different. As I said, normally I draw everything in the clockwise direction, but I'll purposely draw this one in the counterclockwise, just to show that it doesn't matter which way we draw these things. And then I'll draw another one in the clockwise position. I'll call this one I2 and this one I3. And again, your labeling doesn't matter either. You know, I could have labeled this one I1 and this one I3. It doesn't matter your labeling. It's just going to, you know, change your equations slightly. You'll have the same numbers and the same answers. Obviously, these are just variables. All right, so now our ultimate goal is to find the power delivered by the 80-volt power supply. So power for the 80-volt power supply is voltage times current. There is no other short equation because a power supply isn't a resistor, so I can't do like V squared over R or R squared times I. So I have to do V times I. The other option would be to find the power dissipated in every single resistor, but that seems like a lot of extra work because if I look at this, how many branches are touching this power supply? And when I say branches, I should say how many loops are touching this power supply. Well, there's only one loop, I1. So the current through this 80-volt power supply is just I1, or that the current being delivered is simply I1. So actually, if we find I1, we'll be able to find that power of the voltage source really quickly, really easily. Because we know what voltage is, it's 80 volts, and we know what I is, we'll be able to determine that power. Similarly here, I2, that's the only loop touching this 8 ohm resistor. So the power for the 8 ohm resistor, again, we could do voltage times current, but since we're going to be finding currents, it would make sense to use the current squared times resistance. All right, so now that's just kind of setting up what we're looking for. Of course, now we have to write down mesh equations, and unlike the video previously, I'm not going to write down 80 volts, the voltage of the 5 ohm, the voltage of the 26. We're going to go ahead and apply Ohm's law right away. But let's go ahead and start on loop 1 here. So loop 1. Well, first off, I'm going to notice that this arrow comes into the negative side of the voltage source. So that's minus 80. Now, you can start anywhere in this loop. You could start with the 5 ohm. I always just tend to start with the power supplies. So I come into the negative side, it's minus 50. Now remember, the loops you're in are always the positive. So I'm going to have current times resistance. I'll write the resistance first, so it's 5 ohms. Now what's the current through this 5 ohm resistor? Well, there are two loops that are touching that 5 ohm. So let's draw those here. I1 is always the positive direction because I'm in loop 1. So I1's going to the right, and what is I3 doing? I3 is going to the left. So they're in opposite directions, so this would be I1 minus I3. Then we have this 26 ohm resistor, so we need the voltage across the 26. Well, that's going to be 26 ohms times the current. Now again, we're in loop 1, so we know that loop 1, I1 is going to be the positive. Now let's see here. I1 is going down through this 26 ohm resistor, and what is I2 doing? I2 is also going down through that 26 ohm resistor. So this is going to be plus I2 because they're both going in the same direction. and then this is equal to 0. And then of course we would combine like terms and simplify things, and I'm going to go ahead and combine like terms and simplify it and just write it off up here to the side here without doing too much else here. So we'd have 80 volts, because I'm going to move that to the other side, is equal to, well, 5 plus 26 is 31 ohms, not 31 ohms, 31 I1, and then I'm going to have plus 26 I2 minus 5 I3. So that's what I'd have for loop 1. And again, of course, I have 3 unknowns, but I have 3 loops, so we should be fine. Now, if I look here at loop 2, I'm going to erase this here again. Maybe. Just to give us some more room. So again, I do this so I don't have to keep scrolling back and forth between the circuit diagram. All right, that's good enough. So for loop 2, I'll go ahead and do that one in blue. Loop 2 is this one right here, and remember, when we're doing the resistors, it's always the positive. So I'll start with the 8 ohm resistor. So it's 8. Now, the only loop touching that 8 ohm resistor is I2, so this is just simply 8 times I2, and this is my voltage again that I'm summing up, because current times resistance is a voltage. And now I'll just move on to the next one, which is the 90 ohm resistor. And I'm going to notice here that, well, again, I'm in loop 2, so this is going to be I2, and it's positive automatically. But this I2 is going to the left through the 90 ohm. And what's this I3 doing? It's also going to the left through the 90 ohm. So that means, since they're both going to the left, it's going to be plus I3. And then we've got this 26 ohm one, which is 26, and we've already got the currents kind of drawn in there, so we know what directions they're going. So this is going to be 26, and this is going to be I2 plus I1 equals 0. And then sorting this out a little bit, you have 8I2 plus 90I2 plus 90I3 plus 26I2 plus 26I1 equals 0. And then combining terms together, what we'd have here is we'd have 0 is equal to 26I1 plus, well, let's do that addition. I'd have 8 plus 90 plus 26, and that gets me 124 I2 plus 90 I3. So that's my second equation. And then we'll go ahead and do the last one here. You might want to pause the video again if you don't have this written down, because I'm going to erase this. And we're going to do loop 3, which I'll do in red. And again, doesn't matter where you start. I often like just to start if there's one that's obviously only having one loop touching it, like this 30 ohm resistor only has I3 touching it. So I'd start with 30 I3 plus, well, then I'm going to have 90. And again, these are in the same direction, so this is I3 plus I2. And then I have plus 5. Now I'm in loop 3, so loop 3 is automatically the positive one. And then I1 is obviously going in the opposite direction through that 5 ohm resistor right here. And so this would be minus I1 equals 0. And again, kind of multiplying some things out. We get this if we multiply everything out, and then if we write our equation here, we'd have 0 is equal to, well, I have minus 5, and I made a mistake right there. That should be I1. I1 plus 30, no, not 30, 90 I2 plus, this would be 120 plus 5, so it's 125 I3. And I'm going to double check my arithmetic on there. And then now we have 3 equations and 3 unknowns. So we would solve that. So, and if we solve that system of equations, I wind up with I1 is equal to 5 amps. I2 is equal to negative 2.5 amps. And I3 is equal to 2 amps. Now, you might say, well, what happens if I didn't draw them all in the same direction as you do? All that would happen is these would be negative or pluses would change. For instance, you know, let me draw it here in green. If I drew a current instead clockwise there, well, they're just in the opposite directions. So if I did it here, this green current would be positive 2.5 amps. Now all my equations would look different because now I've changed the direction and the green current is going in the opposite direction, so I'd have a bunch of minuses where I'd have pluses, like all of these pluses that I had here, I3 plus I2, they'd all become minuses. So your equations would look slightly different, but you'd still get the same answer. And my point here is that it really doesn't matter the direction you draw these loops. What matters is that you apply them correctly. Now, we know that the problem here, I'm going to erase this equation here. Problem was asking us for the power delivered by the power supply. And to get the power, it's voltage times current, right? Well, let's see here. The current I1 is going into the negative side of the power supply. So my power for the 80 volt, let's take it off green here. The power for the 80 volt would simply be, it's going to be negative 80 because I'm coming into the negative side of that power supply times, and the only current going through there is 5 amps. That's the only current I've got going through there. And so if I do that, you get negative 400 watts, which of course this means that the power supply is delivering 400 watts. Because remember, if you get a negative, that means power is being delivered. If you get a positive, that means power is being absorbed. So the power supply is delivering 400 watts. And then the power for the 8 ohm resistor, remember we said we were going to just do the current squared times the resistance. Now there's only one loop that's touching that 8 ohm resistor. The only loop that's touching it is I2. So this would be negative 2.5 squared times 8 ohms, which if you do that, I'm just double checking my computation here, you get 50 watts. And again, if you had drawn the current and used the green arrow current, you'd still get the same result because negative 2.5 squared is the same thing as positive 2.5 squared. And so that's the result of it. Now the reason I did as I said, normally I always draw mine clockwise, but I wanted to show that you can draw them counterclockwise and clockwise, and it doesn't make a difference. You still get to the correct answers in the end. So it really is just what is convenient to you. Now we're going to look at one more video on mesh analysis, and then we're going to move on, as I said, to some more applications.